Today's topic is how the world works. And I understand that's a big topic, but think about it. That's one of the big questions that we always have in life. Like, how can you tell whether or not something's a good idea? How can you tell the difference between a conspiracy theory and something that may have really happened? How can you tell the difference between a proposal for a project that may work or a proposal that looks like it'll work but never will? So it turns out that there are some really basic principles that you can rely on to dig through this and work out the answer to that question without having to go through 30 years of experience and analysis and MBA programs and accounting. There are basic principles that you start with. And so here they are. I list them as 5. It depends on whether or not the project is secret. If it's a secret project, there are 5. If it's not a secret project, then there's only 3 things to look at. And the first one is whether or not there's a tremendous amount of value. And I'm talking about a lot of value. Now, typically that's money. People want to start a business. They want to make a lot of money. But it can be other things. It can be national security. It can be institutional pride. It can be personal pride. It can be whatever motivates you to create an incentive. So the value has to be measurable in some way, but and most importantly, it has to be huge. It has to be like this monstrous opportunity. Okay, so that's the first one. The second one is whether or not the technology exists to pull it off. Do we actually have the capability? And is it under our control? Do we own it? Can we actually do it? Not just somebody else can do it. Just because Apple Computer can do something doesn't mean that we can do it because they own technology. Okay, so the technology has to be there and we have to have control over it. And the last one is whether or not it's affordable. And clearly, for instance, there's a huge incentive to mine asteroids. In theory, at least in theory, there could be a lot of value in asteroids, but nobody can afford to do that. Nobody can afford to mine an asteroid today. I don't know, it's $100 billion, $1 trillion to do that commercially, and nobody has that money kicking around the bank. And if they did, that wouldn't be the first place they would spend it. So, is it affordable? Okay, maybe, maybe not. So, by way of example, we can look back to the railroads. And the railroads are sort of one of these ubiquitous things. We don't really think about them very much. But early on, in the early 1800s, the railroads were really very different conceptually than how we see them today. Back then, the problem was, ships would arrive at the big seaports, and now you want to move goods inland, and what'd you have for capability to move stuff? You had muddy old roads and maybe cobblestones and in local travel or whatever. It was really difficult to get things inland. Now, we would make use of rivers, we would use every trick in the book, but there were places that were desirable to live, to farm, or whatever, and there were just no natural waterways to get there. So the idea was, okay, let's build a cargo-capable road. And they hadn't invented concrete then, they hadn't invented asphalt then, or vulcanized rubber tires then, or cars, or trucks, or any of that. What they did have in their hands, the technology they had in their hands, was iron. And they realized that, well, iron is really tough, it's really durable, and if we string a bunch of rails end to end and put iron wheels on those rails, well, they won't sink into the mud, and we can have draft horses, and we can pull wagons on these rails, and we can pull stuff inland. We can pull bigger loads inland. So there was a tremendous incentive to be able to do that because seaports and rivers really didn't gain access to the vast majority of the land that was available. And if we could gain access through some other mechanism, there was a huge win there. So the incentive was there, the technology was just emerging, and just about when they started building these first rails and conceiving them, it's like, oh, what's this steam engine thing? Maybe we could use a steam engine instead of a horse. Now, the first steam engines weren't much bigger than a horse. But soon after, it was like, wow, we can scale this up and we can pull unimaginable loads. We can pull stuff overland on rails almost as much as we can go by ship. So the technology facilitated the idea. Okay, so now we have tremendous potential value. We have the technology to support it. Now the affordability, it's like, okay, building rails was expensive. But it wasn't outside of the realm of possibility. I mean, we were able to build seaports, we were able to build ships, we were able to field armies. It was in that sort of category of undertaking. It was expensive, but it was certainly, we had enough resources to pull it off. We could borrow the money to pull it off. And because of the tremendous value, we could get that money back. So in a way, affordability is sort of a two-component thing. One is, do we have the money at all to pull it off? And the other is the expenditure, the investment, reasonable in comparison to the amount of return that we're likely to get? So, okay. So there are, those three things. There's the value, the technology, and whether or not the undertaking is affordable. And if you look at just about any project, it either fails or passes that test. And even when you don't know all of the details, and even when you've just heard sort of some speculative word about it, it's like, well, let's put it to the test. Let's put it to the test and see whether or not, it passes the test. And if you look at like the iPhone, of course it passes the test. Huge potential value. And everybody wants these things. They're practically the Hitchhiker's Guide to the Galaxy if you add Wikipedia to it. Of course, a huge value, huge potential sales there. The technology nowadays exists, and it probably has existed for about the last 10 years. The ability to put that much computing power into a package that's that small. And then the last is the affordability. Did Apple have the resources to design and build these things? And the answer is yeah. Yeah, clearly. I mean, it was bang, bang, bang. I mean, absolutely. So you look at something like that, and a commercial product, or anything. It's like anything that's been successful, you can clearly see that it passes these tests. Now, if you're thinking about something that doesn't exist yet, like Elon Musk's high-speed, wasn't that really a rail system, sort of a vacuum tube system between cities? You can, that might, there's a huge incentive because getting from New York to Los Angeles in 45 minutes could really be very valuable, not just for passengers, but for cargo and having a network of these things that, greatly speeds up the delivery of material goods. There's at least a moderately high value there, and I think if you do the accounting, if you can speed up transportation, that greatly facilitates commerce because you don't have stuff stuck in transit. I mean, that's sort of like you're not making any money, and you're spending money paying somebody to drive a truck. Okay, so you could make the case that Elon Musk's idea for this vacuum tube, I can't remember what he calls it, Hyperloop or whatever, it makes sense. Okay, so let's look at the technology. Well, the technology side, it may be there. I mean, at least on a smaller scale. I guess there are plans to build like a 3-mile version of this to test it out. Okay, the jury's still out on the technology, but it's material science. It's probably within reach. If they're talking about building a prototype within the next year, that probably tells you that the technology exists. Now, the last one is affordability, and that one may be difficult. That may be difficult to come up with, whether or not you could afford to build a system like this from coast to coast or intercity, maybe along the East Coast. It's certainly cheaper, apparently, than building rails that are bolted to the ground, with rattling trains going across them. It seems to be cheaper than high-speed rails that require all kinds of sophisticated control systems and aerodynamics and so forth. This thing goes down through a tube, an airless tube. Okay, so maybe it has improvements on safety, whatever. But I'm just saying, whether or not it's affordable, that third question. I think the jury's still out on that, but it's not a definite no. So I would say that if you put it to the 3-finger test, which is the commercial non-secret test, it definitely passes the value test. It probably passes the technology test, and it doesn't fail the affordability test. It could be one of these similar to the original rails where it turns out to be a lot more expensive to build, but the value is so much greater that it doesn't matter. And you can roll it out piecemeal. It's not like you have to build an entire network all at once. You could build a 100-mile section and then a 200-mile section. So you're not really forced to spend all the money up front. So yeah, it probably passes the affordability test. Okay, so I was also going to talk about secret programs, and I really want to stay away from the whole NSA thing. Let's talk about just spy satellites. Okay, that's National Reconnaissance Office. They're a little less touchy about their programs, I'm guessing. So, okay, in that case, do we have spy satellites? Well, I think everybody knows that. But in terms of, how capable they are, well, we're not quite so sure about that. But the third, in addition to the first three, the fourth test is whether or not we can keep the essential elements secret. And okay, the kind of essential elements of a spy satellite isn't so much its capability. I mean, any regular optical engineer and digital processing kind of person can pretty much figure out what its optical capability is. But operationally, how quickly could we put the thing on target? How many of them are there? Operationally, there are all kinds of secrets. It's like, well, okay, I don't really know, how often a spy satellite could image a particular point of interest on the Earth. Okay, that's the sort of secrets that they probably are able to keep and want to keep. And finally, the fifth one is, if all of their secrets come out, is this a tremendous hit? And the answer is not really. I mean, yeah, everybody knows we have spy satellites. Everybody knows, we can probably, generally see what's going on. The whole being able to read a license plate from orbit, that's probably not true. But then you don't really probably have to read a license plate from orbit to learn a lot of useful information. Okay. So, if somebody were to say, yeah, we have spy satellites up there, I would say, sure, absolutely. Passes all the tests. Okay. So now let's try a conspiracy theory. Let's put a conspiracy theory, a secret conspiracy theory to the test. And of course, the classic one is whether or not the United States actually sent astronauts to the moon. And irrespective of the fact that I am well acquainted with one of the astronauts that walked on the moon, I will make the following test, the 5-finger test. Okay, first test. Is there great value in faking a lunar landing? Well, no. There's no great value at all in faking it, but there is great value in trying to convince people that we pulled it off. Okay, so there is great value in undertaking something that convinces everybody that we've gone to the moon. That's a little shaky, but okay, we'll give that a pass for now. The technology. Did we have the technology to fake it? Well, to some extent, yeah, but the thing is, it was really expensive because we actually had to build like a dozen Saturn V rockets. They're really expensive. They cost, in today's dollars, about $1 billion each to build. And we had to launch them, and they had to go far enough out of view in order to convince everybody standing on the beach that they flew into orbit. And so it's like, okay, well, it costs almost as much to fake a Saturn V launch, for the masses on TV and on the beach as it would be to get into orbit. And it's like, wow, yeah. Okay, well, it's affordable because the government has a lot of money, but, it's like, well, it's almost a why bother. It's like if we can, obviously we know how to get stuff into orbit. If you turn on your satellite TV and you got your dish pointing up into the sky, clearly it's not some seagull up there with a transponder. Clearly we have the capability to put geosynchronous orbiting satellites up. So, it's like, well, and we send up this huge rocket with a tremendously large upper stage and all of this stuff. And it's like, well, it's almost like, well, we've gotten that far. Why bother to just deorbit and pretend we got there? And the other part is that some of the imagery that you see, the imagery in, the conspiracy theorists try to, scrape and pick and try to find little problems. But the fundamental thing is, like, we have hours and hours and hours of film and video and thousands of photographs and all kinds of radio transmissions, and the Russians are listening in, and the Chinese are probably listening in, the Japanese, everybody was watching. And it's like, did a pretty good job of convincing people. And some of the images require lighting that would be extremely difficult to fake. If you've ever watched movies of places that are supposedly happening on the moon, it just doesn't look right. It doesn't look right. The biggest test, though, is the parallel shadows that you see on the moon. It's like the only way you can get parallel shadows is if you have a light source that's virtually at an infinite distance. If you have if you see shows on TV where supposedly you have an afternoon sun coming in the windows, but you see that the shadow spreads out. It spreads out because the point source is 25 feet outside the window. A real shadow is parallel. So if you look at a lot of the photographs from Apollo, you see that the shadows are parallel. And that's really almost impossible to fake. Anyhow, but I'm just saying, okay. This is this technology thing. Did they have the technology? Yeah, they had the technology to fake it, but it was almost the same amount of technology, given the amount of it and tremendous effort that would be involved to build all of that hardware, the vehicle assembly building, the launch pads, all of the testing, and that the hundreds of thousands of people who have personal, eyewitness experience building this thing. It wasn't something that happened with a few people sitting in a boardroom throwing paper airplanes around. This was a huge effort, building real hardware, and the thousands of slide rulers that were worked constantly to try to figure this out, and the effort that went into it. I mean, it's almost like, maybe we had the technology to fake it, but it was the same technology to do it for real. So why not do it for real? Why not do it for real? It's kind of silly. All right, third one, affordability. Okay, we could afford it. We had the money to send up a rocket. We had the money to do Apollo one way or the other, either faking it or for real. But, okay, but it's like, what's the value again? We're trying to convince the Russians and everybody else that we went to the moon for real. And we could afford to build all of the fake hardware that launched out almost to orbit, and we were able to all do this. Okay. But the killer of those last two, could we keep it a secret? Hundreds of thousands of people involved. Somebody would have to sneak a camera in. Somebody would have to bring a tape recorder in. Somebody would have to find the memos that detailed the production process to produce all of this supposed fake photographs and thousands of fake photographs and hours, hundreds of thousands of hours of fake video, and all of the camera returned film from the orbiting service module. They brought back thousands of feet of film that was like 8 inches wide, and they'd have to fake all of that terrain, and they'd have to somehow maintain the conspiracy going on all the way to today, because now we have orbiting spacecraft around the moon that are seeing the landing sites. We can see the lower stage of the LEMs. We can see the tracks of the rovers. We can see shadows of the equipment that was left behind, and it matches up with the old 40-year-old documentation. And so you're saying that we've managed to maintain an absolute ironclad, airtight secret. This government, this United States, has managed to keep it up for 40 years or more. So the question of whether or not they could keep it a secret is like, no way. No way. The conspiracy theorists are picking at little scabs, but if this were a secret, by now the floodgates would be open. And the last test, would this have been an embarrassment if the secret were out? And the answer is, of course, it would completely, utterly, and totally undermine our objective, which was to convince people that we went to the moon. If our secret were found out, it would be an absolute, total embarrassment, and anybody involved would end up in jail. I mean, it would just be a horrible thing, the consequences of that secret being found out. So those last two, could we keep it a secret, and could we absorb the consequences of the secret coming out? Those two would absolutely, positively not let this happen. Kennedy didn't say that we need to fake sending a man to the moon and fake returning him to the Earth. That was not going to convince anybody. The Russians were going to listen in. The Chinese maybe were going to listen in. The Japanese, everybody who had an antenna was going to listen in. And if there were no signals coming from the moon, if they weren't picking up TV signals coming from the moon, they would have raised that flag and they would have said, no way are the Americans actually doing what they're saying. But not only did we convince people by what we said, but we convinced people by what we did. We brought back rocks, and geologists throughout the world are saying, yeah, these are clearly from the moon because of the geochemical evidence and so forth and so on. It's like, okay. So you look at the granddaddy, big, most monstrous conspiracy theory of all, and you put it to the five-finger test, and it falls on its ass. So think about the test. Think about all of the things that happen in the world and whether or not it makes sense that they could have happened, whether or not it makes sense to invest, whether it makes sense to pursue an idea. Just put it to the test. Is there tremendous value? Do you control the technology? Can you afford to get started in a reasonable sort of way? And if for some reason it happens to be a secret program, is it something where keeping the secret is possible, reasonably possible? And someday, assuming like all secrets do come out, if that secret comes out, would it be, entirely destructive? And if you can pass all of those tests, with no heartburn, with no anxiety, well, then probably the thing that you're thinking about either happened, could have happened, will happen, and so on. So that's my pearl of wisdom for today. That's based on many years of experience. You can certainly work out the details on each one of those. But I recommend that the next time some nutcase comes up with some crazy-ass conspiracy theory, just put it to the test. Put it to the test and see whether or not it makes any sense. Because if it doesn't pass that test, the five-finger test in the case of a secret program, or if somebody's just promoting a commercial product, if it doesn't pass the three-finger test, it's probably not going to ever work, and you're wise to steer clear. So anyhow, that's my bit of wisdom for today, and have a good one.